Quadrilaterals, Section 6, Video 4. So this last example that we're doing kind of brings it all together in the like what we did in the previous example with lots of variables. And it also uses the slope, the length, and the midpoint formula. So it puts it in a little more general way. So here we have this trapezoid, OCBA, with midsegment PQ. So we're going to use those formulas we have and the variables we're given to kind of generally put how you would find the slope, the length, and the midpoint. So starting with the first one, we want to find the slope of BA. So once again, it's rise over run. So slope of BA is the change in y. So I have c minus 0 and the change in x. So same order, c minus 0. I went top down, so I do b minus a, which can also just be written as c over b minus a. And that might seem like a weird final answer, but I can't go any more than that because I don't know what those variables stand for, or what they symbolize. So I can go ahead and find the slope of the other side. Slope of CO, rise over 1, y, change in y over change in x, so c minus 0 over d minus 0, which I can also be written as c over d. Now, what does this prove? Oh, it doesn't really prove anything. It shows that CO doesn't have the same slope as BA, which is totally fine because we know that it's a trapezoid, so it must mean that CB and OA are parallel because we need at least one pair of sides that are parallel, and CO and BA are not it. So it doesn't really prove a whole lot other than that those other two sides must be parallel. So I could say, you know, CB must be parallel to OA because we need at least one pair of sides that are parallel. For the length, I'm going to say D for distance, so D of CB. It's just kind of a notation we use. And I can go ahead and do out the whole thing, and I'll do it for this one, do out the whole distance formula, but there's kind of a shortcut when we know it's horizontal. So for this one, I do the square root of x minus x, so d minus b, or actually I might do b minus d, just to keep it consistent. And then I would do c minus c. Oops. C minus c squared, which will eventually give me just b minus d, because you can see we have 0 squared, and then if we do the square root of something squared, we're just left with what's inside. So we have b minus d. And the distance, or the length of OA, this one we can go out and do the whole distance formula for this one, but just if we look at it, we see it's just A, because there's no rise or run or anything. We can just see that it goes from 0 to A, so the distance must be A. For the midpoint, go ahead and find our coordinate pair, where we do, so the midpoint P here, we need to find the midpoint of CO. So we add the x's and divide by 2, and then we add the y's and divide by 2. So that equals d over 2 and c over 2. And here we find the midpoint of Q over here. Do the same thing. Add the x's and divide by 2, b plus a, and c plus 0, which we'll write as b plus a over 2 and just c over 2. And to show that 1/2 times the sum of the bases is in fact the midsegment, we just use what we know about the midpoints to find the length. Oh, actually, we've already figured out the length, so we use those to figure out if it does in fact hold. So we do 1/2 times the sum of the lengths, which we know if we scroll up we have the length of one is b minus d, and the length of other is a. So we add them. Oop. So a plus, and I'm going to do another parentheses just to be safe, a plus b minus d, which I'm going to have to solve, and I'll have to distribute. So it would be a plus b, and then it'd still be minus d. Distribute the 1/2 to be 1/2 a plus 1/2 b minus 1/2 d. I just distributed that 1/2. And I can write it in any sort of way I want, but that would suffice to show what the sum of that is. And then I need to find, if I find the distance between those two midpoints, I can figure out the length of that mid-segment. So I have the 2 points here and here. So if I can find the distance of those two and make sure that those are all equal. So to find the distance between those two, since they're on a horizontal line, so if I want to label this to be a little more clear, I know that Q is b plus a over 2 c minus 2, and P is d over 2 c over 2. Since they're both on that c over 2y plane, I could just find, if I just subtract the x's, I'll find the length. So I know that b plus a over 2 minus d over 2, you see what I'm doing there, that this is this mid-segment, or maybe I should draw it in red here. Since I know, I just need to find the length of that, and I know it goes from d over 2 to b plus a over 2, and I'm just finding the distance that way. So I know it's b plus a over 2 minus d over 2, which can also be written as, if I just kind of break it all out, into 1/2 b plus 1/2 a. So I just split that up that way, and then minus 1/2 d. And I know that I see that those two are in fact equal.